Hello, this is the Bite Weasel, and in this video we'll be continuing our Obby tutorial, this time taking a look at adding some more stages based on the work we've already done. So if you recall from last video, we ended up with 3 different stages. Our jumping platforms that require no scripting whatsoever, our damage bricks that sort of use the collection service to add a touch event to bricks, and then that touch event will, when triggered, cause some small amount of damage. We also use the collection service in a loop to find everything tagged with shooter, and then after like 3 seconds or something, those shooters generate a moving part. That moving part we also tagged with damage so that if I get hit by it, I take a bunch of damage. Cool. We also looked at how we can sort of use attributes and things like that to sort of customize these individual things. Well, even though we've only got, what do we have right now? 2 different scripts. I think we can actually use the concepts that we've already made to create some other sort of compelling areas. So let's take a look at that. Now, the first one that I want to look at is going to work very similar to our damage bricks. So currently in our damage brick script, this sort of adds a touch event into each brick, and that touch event will hurt the player. Well, instead of that, we're going to use the touch event part, but instead of hurting the player, we're going to have the item disappear. Now, you've probably seen something like this before in Obbies, and it usually takes the form of a disappearing staircase. So what we can do is copy area 1, rename it area 4, and move it all the way over here to our new spot. Then what we're going to do is update this so that instead of it having platforms that you just sort of jump across, boop, 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 we're going to have a staircase. So first let's get rid of that cheating platform, and then we'll move these up exactly how we want them. So let's change this to move it by 1 stud at a time. Now we do need these close enough so that you can jump up them, but not so close that you can just walk up the stairs immediately and have absolutely no challenge. So you should take a little bit more time on your game, making sure that the distances are probably equal. I'm just going to guess it for now. I think that was pretty close. And then we'll move this one up here as the safe area. And you could, of course, add more stairs and things like that. So now we need to script these things. The first thing we're going to want to do is have a brand new tag. So select all our stairs, go down here, choose a new tag, and then instead of damage or shooter, we're going to have a vanish tag. So the vanish tag will disappear when a player touches it after, a second or so. So now that we have that, we want to create a new script. And the script is going to work very similar to our damage script. So we can sort of copy this. But first, it might be nice to clean this up a bit. Because right now, we're using the word damage in 3 different areas for the tag that this script is applying to, right? It might be nice if we're going to copy this to only have to update it in 1 place instead of these 3 places. So right at the top, we can just have a sort of constant variable and call it damage. And this is going to be the tag that this script sort of uses with the collection service. So we can update the added signal, which of course fires whenever something with this tag gets added into the world. We can update the remove signal, which fires when something gets removed. And we can update this for loop that basically runs through once to check everything that was in the world when you started. And then they call these onRemoved and onAdded functions. Now, in a similar way, let's update our damage items to be something more generic, like tagged items. That way, we don't have to change that word when we copy this script. So we can add a new script, call it vanish, and then copy all of this and paste it into here. And then we can go in here and update this tag to also be vanish, like that. So now this script is going to be looking for things tagged with vanish. Now the part of the code that we need to change is going to be this part. We still want the onTouched event to look for a character, make sure that character is a humanoid, check that we're not already debouncing, but instead of actually hurting the player, we're going to change the staircase so it vanishes. And how we can do that is basically take the item and say transparency equals 1. So full transparency makes it invisible. And then we can say item.canCollide equals false. So this will basically hide the stair immediately when this happens. So we don't want it to disappear straight away. So let's add a little bit of a wait so that the player has some time to land on the stair and then jump again before it disappears. So we'll say half a second, and then it will come back after 1 second, let's say. So we wait another 1 second, and then we set it back to how it was before. So transparency to 0, and canCollide is true. So with just a very little change to our existing script, we now have a brand new area that we should be able to try out. Now, assuming that I can make it all the way across our jumping platforms, our damaged bricks, and then avoid these sort of, oh dear, oh no, our dangerous bullets, which I didn't. So I'm going to show you a little trick. What you can do here is sort of go into edit mode, move your camera into position, and then instead of choosing play, there's a little drop down here called play here. And what that's going to do is it's going to drop you directly where you were in the edit mode. So this will be a nice handy trick for us to get and test our latest areas without needing to start from the beginning every time until we have the script that sort of stores our latest stage that we got up to, which we don't have yet. So we'll use play here for now. So now we're going to test this. I assume I can't just run up the stairs. I am going to have to jump up them, but you can see they sort of disappear behind me and then they come back. So if I was to spend too long on one stair, oh dear, I fall down. And then right now we start all the way back at the beginning, which is unfortunate. But we can stop and choose play here and then start from that area again. So there we go. We have a nice disappearing staircase sort of track. So of course you can add more stairs, customize those timeouts, even use attributes to set those if you want them individually. So if you wanted to, instead of making the part disappear immediately after 0.5 seconds, we could sort of replace this with something that causes it to fade out over time. So we can use a loop and sort of change the transparency in that loop. So that would look something like this. We have a local duration equals, half a second like we had before. And then we're going to loop. And we're going to loop between, so I equals 0 and that duration, right? But we're going to do it in increments of some small amount so that we can update the transparency by a small amount every time we're going 0.01 second. So what does that look like? Well, the first thing we need to do is actually wait. Otherwise, it will happen immediately as we loop real quick. And so we will wait the same amount as our step value, which is 0.01, so that we know, we're looping through until 0.5. We're doing it this many times. It means if we wait that many times, we'll have waited a total of that many duration seconds. Okay, then we can just update the transparency of that item to be I divided by the duration, which means that we'll go from 0 to duration. Eventually this will reach 1, and that's when it will have disappeared. We'll exit the loop, and so the transparency will then be 1. So if we go back and play here, hopefully my camera's still in the right place, we can now see that the stairs slowly fade out beneath us before disappearing entirely. But they still come back immediately, and that is fine. But of course, you could use this exact same code down here if you wanted them to fade back in. But I think that's okay. So there we go. We have a brand new area, and this time it is disappearing stairs. Next, we're going to add a real easy one. So let's just duplicate area 1 again. But this time it's going to be area 6 and move it all the way over here. But I guess now we have to put it up these stairs, which is fine. We can just move it up. And about there, is that level? Yeah, close enough. So now I think what we can do is use our damage tag to make a nice, easy, pretty common sort of obstacle. Let me show you what that looks like. So here we'll just stretch out these things. Maybe we'll make it even a bit wider than normal by just moving that over, stretching this out. Now we're going to create a couple of new models. Now, a model, if you recall, is just a collection of parts together that has a physical presence in the world. But it's a nice way of keeping things together, like what we're going to create here. So I'm going to put these like this, and I'm going to move this all the way up here. And then I'm going to duplicate this one. I'm going to move it across about halfway, I would say. In fact, we might have to make this whole thing a bit wider, but that's fine. And then we'll move it up here, and we'll move it across. Can you see what I've made? I've made a door frame, right? So we'll just change all of these into a different color, and then we will make one part that is the center. And you've probably seen this sort of thing before. Essentially what we're going to have is two doors right next to each other, and the player has to choose the correct door to go through. So we'll make one sort of a bluey color, partially transparent. And then the other thing that I want to do is just scale this down a tiny bit so that it's a lot thinner. Oops. Like so. There you go. So that should be mostly in the middle. Close enough. So now I'm going to take all of these parts that correspond to my door. I'm going to right click and I'm going to group as model, and I'm going to call it door. Or doorway, I suppose. So there we go. We have a doorway, and the most important part of our doorway is actually the center part. So we'll call that the center. And now I can duplicate this door and just have them side by side like this. And this one, I will change the center color to be something else. Whoops. So that you can see a difference. There we go. Some sort of pink and some sort of cyan color. Now, I do want to move these two so they are in the center, sort of like that. That means I should just make this a little wider. I don't want the player to be able to jump around them, but you can sort of spend a little more time making sure that they can't jump over these things, they can't jump around these things, and things like that. For your game. But for now, we're going to just duplicate these two doors. Duplicate so that we have a whole bunch of them that you need to go through in order to pass this part of the area. And now the trick becomes is just picking one side of these doors and adding a tag to the center of it to be damage. So this doesn't even involve any new script. We're just going to use the script that we already have. So here I'll also say damage amount, because I want to customize the door's damage amount to instantly destroy the player. So 100 damage should do that. And then we'll do the exact same thing on these other doors. So let's say this one is the correct one for the next set, and then this one is the correct one, and then we'll say the final one is not that one, the other one. Actually, these are the incorrect ones, because I'm going to add a damage tag. I'm going to add a damage amount attribute, and I'm going to set that attribute to a number that is 100, which means instantly destroy. So now I should be able to click play here like we did before, and now have some nice doorways. So one of these I should be able to pass through, and I forget which one it was. Oh, not that one. Okay, let's try that again. So one of these I should be able to pass through. It's, oh, that one. No, incorrect. So one thing that I did forget to do, and you should do before you sort of duplicate these things, is that we want to be able to pass through the center of every single one of these. So I'm just selecting every center part, and I'm going to turn off can collide. So that means can touch is still true so that we can do the damage touching, but can collide is false so that you can walk through them. There you go. Now we should have the right. So I can pass through this one, but that one's incorrect. So now if I play again, I now know that this one's correct. This one's correct. I forget which one is correct. That, and then maybe this one. Yay, we did it. But of course, if you go through the incorrect one at any point, they destroy you. So that is a really nice, really quick way of just adding yet another obstacle. And the only thing that we had to do was use a tag and a customized damage amount. And that's it. We've got an instant new area with a brand new kind of obstacle. And since we are sort of on a roll here, I kind of want to just make one other area that requires very little scripting, just to show you how to do it, in case you're curious about your game. So here I've duplicated 6 and I've made it 7, but I'm going to get rid of all these doorways. And I promise after this one, we'll go back to one that requires some more scripting. So for here, though, it's going to be very similar, but instead of a doorway that you have to choose between, it's going to be which path do you go down. So make sure that you do sort of make it long enough that the player can't just jump all the way across. So something like that. And then we will group this into a model just so that we can see it. And we'll call it bridge. And we will duplicate this bridge. We will move it across. We will do the same thing, something like this. So now you have to sort of pick which one of these is going to be the correct path. And the other two, of course, are going to be incorrect. So we will pick this one and this one to be incorrect, then this one and this one, and then this one and this one. And for these incorrect ones, oops, we will just go down here and we'll choose can collide to be false. So we're not going to add a damage tag, although you certainly could. Instead, we are just going to use the collision mechanism. So now if I go here, all of these look completely sane, but only one of them is correct. And I think it's this one. So if I do this, and I do this, and I do this, I successfully make it. But if I was to choose incorrectly at any point, they don't have collision on them, so you just fall through. So another very easy, very basic mechanic, but it is a common staple in obbies, so now you know how you can do it. Of course, take a little bit of time, make it look a little better, maybe even longer, your choice for your game. Okay, so we have 7 distinct areas now. Some that require no script at all, like our platforms here and the jumping platforms at the beginning. Some that use our damage script, like these doors and these damage blocks. One that uses a vanish script, and then this one that uses bullets. And I think for our 8th area, what I'd like to do is sort of reuse some of this code where the bullets move across the level. And so I want to focus on area 8 being a moving platform area. So we can sort of start out by just duplicating area 7 as usual, making it area 8 and moving it across. Now what I'd like to do is take script that works very similar to our bullets, but instead of moving a bullet around, I'd like to move a platform around that the player has to stand on. So let's take a piece of this bridge out of here and delete everything else. So this will be our moving platform. We'll make it a bit smaller, but also a bit wider so that the player can actually have something to stand on. And because they're going to stand on it, let's make sure that can collide is turned on. We want them definitely to be able to collide with this so that they can stand on it. Now, another important thing is to turn off anchoring, because we're going to make this move across the world. So we don't want it anchored in one position. We want Roblox to be able to move it around with our code. Now, we've seen a few ways to sort of move things around in Roblox. The first thing that we tried was our assembly linear velocity, and this sort of fired a bullet out which was affected by gravity, so we saw it arc down into the void. But instead of using that, we decided we want the bullets to move just horizontally and ignore things like gravity. So to do that, we added a linear velocity constraint, and that basically constrains a bullet's movement to go in a single direction forever. In our case, it lasts for 0.5 seconds because the debris surface then cleans it up. So a linear velocity is one kind of constraint you can use to move items around the world in Roblox. Another way to move items would be to do something similar to this while loop here. So instead of adding time after a certain amount of waiting in this loop, instead what you could do is update the position of the item over and over again. You can imagine instead of setting shooter's eye to be +1, we could say dot position equals +1, and you could move it over some amount of time. The problem with doing it this way, either in a spawn task loop or in something like the run service heartbeat, is that players won't be able to interact with it well. Because the way that players jump onto items and move with other items is that Roblox has to calculate its position. And if you're manually updating the position in some sort of loop, Roblox doesn't know where the player and your item are going to intersect, and so it gets kind of messy. So the correct way to make a moving platform is going to be with a constraint. Now, we don't want to use a linear velocity constraint because we don't want our platform to move forever in one direction. Instead, we're going to use something called an AlignPosition constraint. And an AlignPosition constraint allows you to move one item towards another item. And that's going to be perfect for us. So let us sort of set up what that might look like for our moving platform. Right now, we have this part that I'm going to call move because that's the item that's going to move. But I want a target that this platform is going to move to. So what I'm going to do is duplicate it and move it across here. Whoops, I did not duplicate it. I'm going to duplicate it and move it across here. Then this I'm going to name as number 1. This is going to be our first target. I'm going to make sure that our target is anchored and cannot collide, because I don't want the player jumping on this target. And also, I'm going to make it much, much smaller by setting it to 1 in size, and I'm also going to make it invisible. So this is going to be just a point in the world that our platform is going to move to. And the idea is that I could have a whole number of these depending on where I wanted my moving item to move to. So I could duplicate this and move it over here and call it number 2, for example. I could duplicate another one, move it over here, call it number 3. And these are going to be different places in the world that I want the platform to move. So we'll have a final one, 4. And so the idea is that this platform will move towards number 1, and then number 2, and then number 3, and then number 4, and then back around to number 1. So to do this, let's group all these things together. So we can click them all, we can right click and choose Group as Model. And our model we can call Moving Platform. Right? And now we'll set the base primary part of our model to be the moving platform because that's the most interesting piece. So there we go, we have that all set up. Now the other thing I'd like to do though is be able to loop through these particular parts, these children of the moving platform, much more easily than right now. So what we can do is group those into a submodel and call that submodel a specific name like targets. Now in our script, we're going to have a reference to the model, and then from the model, we'll able to get our moving platform by going .move, and we'll be able to get every single target that our platform wants to head towards by looking at the .targets.children. You see? So we can add as many of these as we like under our targets, and that will just give us different places that our platform can move to. So that'll be a nice way of accessing that. So there we go. We have this moving platform sort of set up. Now what we want to do is just give it a new tag that we can use in our script. So let's call it a mover. So this is different to our existing tags of damage, shooter, and vanish. We now have a mover tag. So now that we have the mover tag, let's make the mover script. So we can make a new script and call it mover. Now we're going to want to get rid of this and replace it with code that basically moves our platform from here around these targets. So how can we do that? So here in our shooter script, we have something that I think will be very useful. So here we sort of loop through all of our shooters, wait some time, and then after that time has expired, fire a bullet. And I think we're going to want to do something very similar. We're going to want to loop through all of our movers, and after some time, move to the next target. Right? So we can take this, and we can copy it, and paste it here into our movers script. Now we'll also need to clean it up a bit, so let's take the collection service, which we also need. Similar to how we updated our damage script to be more generic, let's do that here in our movers script. So we can have a tag called mover. That tag can be used here in the collection service as we sort of find them all to loop through. And then instead of shooters, we'll use tagged items. Right? And so now, as we're looping through our movers, we're going to wait a bit of time, but we don't really care about a fire rate. Instead, it's probably something more like a duration, right? So how long do they have to move to this target before we switch to the next one? So we can change that to duration. And then instead of firing a bullet, we'll say move to target. And we'll pass in some sort of target. So that's pretty good. Now all we need to do is fill in some of these blanks. So we can have a local function, move to target, that's going to take item and target. Right, kind of like that. Now we still have some work to do to figure out how to grab the target from this, but I think first I need to show you how on earth you can move the platform at all. So in our shooter script, when we want to move the bullet, we create a new instance of one of these linear velocity constraints. Well, we already talked about the platform is going to use an AlignPosition constraint, but it definitely needs to make it very similar to how this one's made. Now in this code, we create the bullet every time it gets fired and then add one of these to it. Our mover platform is going to want to only get one of these AlignPosition constraints once. So how can we add some sort of initialization code that only happens once? Well, we've seen that in our existing scripts. We can use the collection service to find all the existing items in the world that have a tag, or we can find them when they're added dynamically, and we can do some cleanup code as well when it's removed. So we can copy all of this from our damage script, and we can paste that into our movers script. So it's sort of becoming a combination of the damage and shooter script. So this is all good. Like that tag is set to movers. We're going to call onAdded and onRemoved. OnRemoved will clear our state, and onAdded is where we'll create our state. Right? And the state that we want to add first is really going to happen much like this. So we're going to find our item, and instead of creating a linear velocity, we're going to create a different kind of constraint. The first thing I want to fix, though, is that here we're expecting the item to be a base part. This is no longer true. It was true on all our damage scripts because we were tagging things that were only a base part. Now we're going to be tagging stuff that is a model that has a submodel called targets. So how can we get a nice type here that allows Roblox to give us wonderful IntelliSense when we press the dot? Well, you can do that by specifying your own kind of type. You don't need to use a built-in type. You can make your own. So we can say type mover model equals, and then tell it what kind of type it will be. So this will be a model. But we can get more specific and say this model is going to be combined with this ampersand symbol here, a table like this, and this table is going to be the children parts. So we're going to have a move base part. So over here, I can type move, which is a base part, comma, targets, which is itself a model. So now we have this mover model type that describes this structure. And this is the sort of structure that we must have for our mover script to work. So then we can say, instead of the item being a base part, all of these places it's going to be our new mover model type, including this item up here that we don't have a type for yet. Cool. So that's good. Now we know that this item is a mover model. So if I was to say item dot, you'll see I can get access to the move base part and that targets model, which has children in it. Neat. So how do we create our correct constraint? Well, the first thing to do is it's not a linear velocity constraint. It is an align position constraint. And it's not going to be attached to the bullet, but rather the item.move base part, right? We could also update this to say AP because it's an align position constraint, but it's very similar. We don't have a vector velocity though, so let's delete that and replace it with something else. Well, the way that align positions work is that they must have an attachment very similar to the linear velocity. So we can create a new attachment and add it to our item move. But the way that align positions usually work is that they also have a second attachment. And what happens is they move attachment 0 towards attachment 1. So in this case, they would move item.move towards one of our targets that has an attachment on it. But we don't really want to have to create a whole bunch of different attachments to each one of our targets because we might have a whole bunch of them. So instead, we can actually tell Roblox that our align position is going to have a different mode. And that mode is called a position alignment mode of type 1 attachment. So the way that this works is it tells Roblox that instead of having two attachments, a source and target, we're only going to have a source. And then when you want to move it, we actually do that by setting the attachment.position. So we can set this to whatever position we want. So for example, we would grab item.targets.1, right? That would be this first target. However, because we've numbered them, you can't really use a dot here. So what we can do instead is say find first child called 1. And we have to grab the position from that. Just like this. So now, Roblox has created an align position constraint for us, and we've attached it to our move item. We've said the mode is only one attachment, so that attachment 0, which is we've just created on our move, gets moved by the position towards this position. Cool. Now we do have a few more things to add. We still need this same max force, which if you recall is how much force this constraint can take before it breaks and Roblox regular collision and physics detection sort of takes over. Well, we never want it to break really, so we can set it to math.huge. And in a similar way, there is a max velocity. Now we don't want it to break, so we'll set it to huge. And the final thing is a thing called responsiveness. And this is sort of how often Roblox will come to this constraint and sort of update its position. So you can sort of think of this as speed. So we can hard code that right now to be 10, but this would be a good place to grab a new attribute from for speed. So right now that's fine, and we can have that. So this is pretty nice. We're going to have created an align position constraint, attached it correctly to our item move, and then set the position that we want it to move towards to be our first target. So this should work nicely for initialization. But when we actually come down, we're going to need some way of knowing what is our current target so that when we move to the next one, we know which one of these it is. So we're going to have to update our state a little bit. Previously, our state which was this tagged items. Item was just a single number, and that was the fire rate that we were using in the shooter script. Now we're going to need a table of different things. We'll still sort of need that timer value, but instead of having only that, we will have like a target index. And we can start that one at target 1, which is the first one. So that's nice, but now we have to go up here and change this. We don't need this initialization code because we're now doing it with the collector service on added, but we do still need this timing code. So now our state is under .timer for all these numbers, so we can just update that. And now we can grab the target based on the next target index. So let's do that. We can say tagged items I, which is the state for this particular mover, dot target index plus equals 1. Right? So we've basically just incremented the target index every time we want to move after a certain duration. So that's nice. But what happens when we get to the end? Well, we're going to have to set it back to 1. So we can have a little check here that says if tagged items I dot target index is greater than the count of these children. And so the way you get that is with a special hash symbol, which means count of an array, and then you give it the array, which is going to be I, which is our moving platform model, dot targets, which is our submodel, get children, which will return the array of the children. So we're saying if our target index is greater than the count of the children, then we're going to say set it back to 1. And now we can simply grab the target by saying local target equals this target index, but as a name for the child under this. So I dot targets find first child, just like we did up there, and pass in the name, which is this target index combined with a string, right? So the first time it comes in here, we'll have set target index to be 1, and we've already updated the position there. It waits a little bit, then it will come in here and increment the target index to be 2, and we'll find I.targets 2, right? We'll find this one, and we'll pass that into our move targets. We will wait a bit, and then we'll increment it once more. We'll find 3, and then we'll get I.targets.3. That's really nice. And when it eventually it gets to 5, it's going to be too big, and it's going to start back at 1. So the only thing left to do is fill in our move function. And we've already seen how you set the position to where you want to move to, which is right here. So we can say attachment.position is, instead of this, it's whatever target they sent in. And we can actually update this to say, well, that's going to be a base part. And we need to grab access to AP, which was our align position. So we can say item.move, local AP equals item.move.align position, because that's going to be the name of the align position that we've created. So I know that was a lot of code. Hopefully that makes sense, though. We're sort of looping through every single mover from our collection service, waiting a little bit of time, and then once that time has elapsed, we're moving towards the next target. So that should happen in a nice loop. We start at 1, then 2, then 3, then 4, then back to 1. So we can check it out, but first we sort of need to do something with our duration and maybe our speed up here. So what we can do is none of our moving platforms, we only have one, but it doesn't yet have an attribute called duration. So we can use a little shortcut here to say or, and then have a default value. So this will look up the duration, and if this is nil, Roblox will say, oh, it's nil. I should check whatever's after the or. And so that will be 1. So this is a nice shortcut way of saying, hey, grab the attribute, but if it's not there, use a default value of 1. We could do something very similar with responsiveness here. We can say get attribute called speed, or if that doesn't exist, default to 10. course, it has to come off the item, not I. I is in our loop down here. Item is the name of it up here. So in theory, this should mostly work, but actually I've spotted a small mistake. When we move our align position, it's not the attachments position that we have to set, it's the align position constraints position. Okay, so previously I had attachment 0.position. We actually want AP.position. So don't move the attachment point around. That's just going to get kind of weird because it will change relative positions. Change the actual align positions constraint position to be your target. And then Roblox will attempt to move the attachment point to the align positions position. A lot of word positions there, but this should be correct. So let's try it out. Now, I think our camera is in the right spot for a play here. And we can see that it is indeed working. It is moving to each point, and it's taking a duration of 1 second, and then it's moving to the next target. Now, obviously, there's a slight problem. You may have noticed that although it is moving correctly, it's also rotating kind of randomly. And that's because we only constrained the position. When it's accidentally clipping one of these blocks that can't move, Roblox is still calculating that collision, and it's sort of trying to update its rotation based on what would happen in that collision. And because we haven't constrained it, it's going all sorts of places. So that's not going to work for us. So how we can fix that is very similar to how we constrained the position. You can constrain the rotation. And to do that, you use something called an AlignOrientation constraint. And it looks very, very similar to this thing. In fact, let's just copy this and make a new one. So instead of align position, it's called AlignOrientation. So this basically constricts the rotation or orientation of an object. So we'll make this AO, 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 AO. Right? It's going to be very similar. It does also have a mode that you can set, but it's not a position alignment mode. It's an orientation alignment mode. We definitely want one attachment, but we don't need to create a brand new attachment. We can literally use this one that we already have. So that's going to work for us. And then the only thing we want is none of these, but instead a property called rigidity enabled. And we're going to set this to true so that it never rotates and it just stays on the alignment that this attachment was created with, which is going to be, 0, 0, 0. So now that should work a little better for us. So now when it clips into that platform by accident, it's no longer spinning uncontrollably. It is constrained in its orientation to be flat. So now I should be able to stand on it. How cool is that? We've got a whole moving platform with script very similar to what we already made. So it shouldn't be too difficult to understand, although the constraints are a bit wonky. So definitely double check how these things work, the align position and align orientation constraints. But everything else is very similar to the shooter script. And this bit is very similar to the damage script. But now we have that, I can already think of some cool ways to use this technique to make other obstacles. So let me show you an area 9 that I'm thinking about. So we can copy this. We can call it area 9, just like we've done so many times before. And instead of using our moving platform to move between these things, let me show you what I have in mind. So I'm just going to grab this, I guess, and copy this and paste it into my area 9 and then move it all the way over. I want a flat surface for this thing to work on. Does it fit exactly in there? I mean, it's close, but I think I do need to move my stage just a little. Okay, now I'm going to sort of convert our moving platform into a deadly laser beam. We're going to have a laser beam. And let me show you what that's going to look like. So first, our moving platform is no longer going to be a platform. It is instead going to be a really thin beam like this. We're going to color it red for danger. And we're going to make sure that it is positioned somewhere along this platform. Right, now I'm also going to duplicate a bit of this and make it into a nice looking frame for our laser beam. We're going to have these two. We shouldn't really be called move anymore, and they shouldn't really be red. Let's have them black, and let's call them frame. Okay, so we have those, and we do want these ones to be anchored. Can collide, doesn't really matter. But what's going to happen is we're going to have this laser beam move up and down on this frame. So how can we do that? Well, we're just going to move these target points. Point 1 can be at the bottom, almost exactly where this current one is. Right like this. And then point 2, you've guessed it, is going to be at the top. So about here, and then up at the top of the frame, kind of like this. Don't know that that's exactly where we want it, but it's close enough to show you what I mean. So really what we need to do is take the position of this C-frame and copy it into both of these so that they are aligned perfectly, and then move this to the top of the frame, like so. And now the magic becomes clicking our move platform and adding one more tag, damage. We can also set an attribute called damage amount, much like we did with the doors, to say that this is going to do 100 damage and kill you instantly. Okay, so now we have a laser beam that should, if I've done this correctly, move up and down. We can also turn off collision for this one because laser beams don't tend to block you, but it doesn't really matter. So let's try this. So with very little code, just moving stuff around in our hierarchy, we have this cool looking laser beam. Oh, that if I run into is going to shoot me and lose all my health. So I guess if I jump over it, it should work. Cool. But we can also specify its speed, right? We actually added that code in here. We just haven't used it yet. So go to our laser beam, go down to attributes, add a new number attribute, call it speed, and set it to be, slower, like 5. And then we can duplicate one of these things, move it down, whoop, and change its speed to be 15, so faster than default. Right, let's take a look to see how that works. Now you can see this one's moving slower, and that one's moving faster. Oh my gosh. Now this one's moving so slow that it's changing targets before it reaches the other end. And that means its duration is too low. But we can fix that by just adding a new attribute, a number, calling it duration, and letting that duration have a little longer before it changed targets, like 2 seconds. So now you should see it get all the way to the top, wait a bunch, and then move all the way down. There you go. 2 seconds might still be too slow, but it is getting further above there. Oh, so close. But how cool is that? With very little changes, you are able to add 2 kinds of moving platforms, right? A moving platform, and a beam. And you can even, customize these things. You could increase the frame, move it up here so this one's much, much larger. And you can basically do whatever you want because the code is going to work for you. And all you need to do is move around these end point and start point targets. And we've already seen that you can either have 2 up and down, or you can have 4 that this one uses. 1, 2, 3, 4. You can have any number with the code that we have written. So it's really nice when you have reusable code like that, and it just sort of works. Now, obviously, I did not make those frames the correct height, but look how cool this is. Yay, we did it. But if we accidentally get touched by one, oh, it chopped us in half. Nice. Now that's going to bug me a little bit if we don't fix it. Let's just make them the same height. Is that right? Might be a little too high. Move it down one. There we go. So how cool is that? We've already got, I don't know how many made this episode, but a whole bunch of new platforms. Let's try it from the beginning. So we can switch back to play. Now this one I was cheating at. We should get rid of that. The damage bricks, super easy. Hopefully it's more complicated on yours. These bullets, slightly more challenging. Disappearing stairs, as long as your jump button works, that works. Uh-oh. I don't remember which one was safe. Was it this one? No, it wasn't. Oh. But anyway, super, super fun in this obby. Let's just go back to where we were and play from here. So it's definitely this one, then this one? Okay. Then it was this one again, then this one. Cool. Oh, now this I don't remember, but I think I did it diagonal like this. And then our moving platform, I'm going to have to wait. There it is. We can stand on it. We can travel to the other side. And then I think I can just go under that one. This was a bit fast. This one I can definitely go under. We should speed it up. There we go. We did it. Yay. Good job, everyone. So that's it for this video. Thanks so much for watching. If you enjoyed it, like and subscribe, leave a comment, ring that notification bell, all that good stuff, and I will see you next time.